It is given the next information. In this question you will be investigate the maximum product of positive real numbers with a given sum. Consider that two numbers x1 and x2 are real positive such that x1 plus x2 is 12. Find the product of x1 and x2 as a function f of x1 only 2 marks. So f of x becomes x1 times x2, and we need in terms of x1 only, so x2 is 12 minus x1, and hence we get the required expression in terms of x1 only for this product. B. Find the value of x1 for which the function is maximum 1 mark. So we need x1 so that this function is maximum, and you may find it directly. You can see it's a quadratic function. If you expand, you get minus x1 squared plus 12x and 1. And if you consider the derivative, it becomes minus 2x1 plus 12. And since it's turning point, maximum minimum, it should be 0. And we can see that x1 is 6. Or sum, it's like a perimeter, and product, it's like area, and we know that for a given perimeter a square has the greatest possible area, and to be a square it must have equal sides, and it may be 6 and 6 only. So x1 is 6. And hence shows that the maximum product of x1 and x2 is 36 1 mark. So it's just 6 times 6, it's 36. 6. Since it is given or asked to show that, so let's write that it's 6 multiplied by 12 minus 6 is 36. Consider m and of s to be the maximum product of n positive real numbers with the sum of s, where n is positive integer and s is real and positive. For n is 2, the maximum product can be expressed as m2 of s is s over 2 squared. C verifies that m2 of s is s over 2 squared is true for s is 12 1 mark. S means sum, so when s is 12, m2 of s it's 36, it's from B, and s over 2 squared is sum, it's 12 over 2 squared, which is 6 squared is 36. It's from B, and it's from the statement, and we can see that therefore, or hence, the statement, since 36 is equal to 36, hence the statement is true. Next, consider n positive real numbers x1, x2, and so on up to xn. The geometric mean is defined as x1 times x2 times so on up to xn, and it's actually a root of degree of n, or to the power of 1 over n. It is given that the geometric mean is always less than or equal or equal to the arithmetic mean. So this is less or equal than x1 plus x2 plus so on plus x n over n. It's just the usual mean or average. di shows that the geometric mean and the arithmetic mean are equal when x1 is equal to x2 is equal to xn, 2 marks. So let x1 to be equal to x2 and so on to be equal to xn, and let it be just x, and hence the left hand side becomes x to the power of n because it's a product of n equal terms, and to the power 1 over n it's just x, and the right hand side, or the arithmetic, it's geometric, it's the arithmetic mean is nx over n, which is just x. Shows that the geometric mean are equal to, and the arithmetic are equal to when x values are equal. Yes, next, use this result to prove that n of s is s over n to the power of n. So what is n of s? Or actually, what is s? S, it's the sum over x value. So it's x1 plus x2 plus so on up to xn. And n of s, it's the product x1 times x2 times so on up to x to the power of n. It's n of s. And using the previous statement, it becomes x1 times x2 times so on x to the xn, and to the power 1 over n is less or equal than x1 plus x2 plus so on plus xn over n. And from the previous result, we can get the maximum possible value of the left hand side. It means they will be equal for same or equal x values, and when all x values are equal, or we can write it as the maximum product when all x values are equal, and hence it becomes x to the power of n to the power 1 over n is equal to s, because its sum is s over n, and x to the power of n, it's just our product, so it becomes mn of s is equal to n to the power 1 over n is equal to s over n, and hence mn of s is equal to s over n to the power of n. We just raised both sides to the power of n. So I repeat, use this result. Yes, use this result. It means we should use that the maximum value of a product, or yes, the maximum value of this product when all x values are equal. And actually, it's not necessary to write this statement because it is given directly from the previous question. Yes, okay. Next, E. Hence, determine the value m3 of 12. What does it mean? It means sum is 12 and there are 3 numbers, and using this result we can see that it becomes 12 over 3 to the power of 3, so it's 4 to the power of 3. It's 64. And next m4 of 12, and also we need m5 of 12. So it's 12 over 4 to the power of 4, it's 3 to the power of 4, it's 81, and 12 over 5 to the power of 5, it's 2.4 to the power of 5, and it's 79.6 with 3 significant figures. For z is positive integer, let p of s denote the maximum of s, not of x, denote the maximum value of mn of s across all possible values of n. F. Write down the value of p of 12 and the value of n at which it occurs to max. So we need just find the maximum possible product when sum is 12. And n is parameter, it's the number of numbers, and a function which gives the maximum possible product for n and for a given sum, it's this one, and we need just actually maximum of a function 12 over n to the power of n, and we can use a calculator and if we consider function 12 over x to the power of x, we can consider a table or a graph, and you may find the maximum from a graph, and notice that if you find the maximum you get not an integer for n, so lower bound, upper bound, and guess, and you can see that you get n is 4.4. So since n is integer, you should check adjacent values, so you need just find the values of a function. For x is 4 and x is 5, and just take the greater value. Or if you use a table, it's clear that for values when n is 3 we get 64, when n is 4 it's 81, and when n increases values decrease. So the maximum is when x is 4, so maximum at n is 4, and the maximum product is 81. G. Determine the value of p of 20 and the value when at which it occurs, 3 marks. It means sum of some number of numbers, which is a parameter, is 20, sum is 20, and we need the maximum possible product. And again, a function e becomes 20 over n to the power of n. And we need to just maximum. So let's consider 20 and just table and we can see that the maximum value is for n is 7, so there must be 7 numbers to get the maximum possible product. Or if you use a graph, you again you will get n to be decimal, so you check adjacent values and just take n corresponding to the greater value of a function. So it's n, and maximum it's 1550 to 3 significant figures when n is 7. It may be not correct to write this because it's not p, it's just a product in general as a function, and p it's a maximum possible product. Okay. Consider the function g defined by ln of g of x is x ln of s over x, where x is real positive. A sketch of the graph of y is g of x is shown in the following diagram. Point A is the maximum point on this graph. It is given a graph, something like this, and A is just a maximum, and it's a function g of x. H, find in terms of s the x coordinate of point A, 6 marks. So we need maximum, and we know that to be maximum derivative must be 0. So we need to differentiate this expression to find the maximum point. So how to differentiate the left hand side? We should apply chain rule. ln of more complicated argument, apply rule for ln. It's 1 over argument, and argument derivative is equal to, we can see a product, so we should apply product rule. X derivative is 1, so just ln s over x plus x derivative over ln. Again, it's 1 over argument and argument derivative, which is ln s over x plus x squared over s, and s 1 over x derivative, it's minus 1 over x squared, minus 1 over x squared, and it becomes ln s over x of s of x minus 1, and hence derivative g of x, we just multiply both sides by g of x, becomes ln s over x minus 1 multiplied by g of x. Since and actually we need the derivative to be equal to 0, and since g of x cannot be equal to 0, it means ln of s over x is equal minus 1 is equal to 0, or it's just 1, and just undo ln. What does it mean? E to the power 1 is this, s over x is e to the power of 1. And what do we need actually? We need x over the maximum point. So x is s, which is the sum of numbers divided by e. I verify that g of x is mx of s. mx it's a product, and it is equal to this. So let's consider this statement or given expression ln, and just let's express g of x, and we can move this x to the power of this argument of ln, so it becomes ln of g of x is ln of s over x to the power of x. And since ln of something is equal to ln of something, we can just equate arguments, so g of x is equal to s of x to the power of x. And comparing with this, mn of s is s over n to the power n, and we can see that it's absolutely the same, but x instead of n. Verify that g of x is m x of s, so it is equal to m x of s, where x is positive integer. 2 marks. J. Use your answer to part h. What is h? It's this maximum x coordinate. To find the largest possible product of positive numbers whose sum is 100. Give your answer in the form, it means just scientific notation, 3 marks. So we should consider the next function, so product, it's this in general, or our g. So g of x, where x it's a number of numbers, is equal to 100 divided by x to the power of x. And since we need a maximum, we know that maximum if for maximum point x is sum divided by e, so it's 100 divided by e. And 100 divided by e, it's approximately 36.8. And what does it mean? It means that the maximum when x is this value, but since x or n is are positive integers, we should just check g adjacent points, g of 36 and g of 37, and choose the greater value. And if you use your calculator, g of 36, it's just 100 over 36 to the power 36. It becomes 9.40 times 10 to the power of 15. And g of 37, it becomes 100 over 37 to the power 37. It's a function in general, but we consider a maximum point, and it happens when x is this value. So it's 9.47 times 10 to the power of 15, and we can see that this value is greater, and hence the largest possible product is 9.47 times 10 to the power of 15. And that's all for this question.